Okay, here we are, Algebra 1, Chapter 1.2, solving multi-step equations. This is, again, some more review. Let's look at some two-step equations. Giving us decimals. 1.5x plus 15 is equal to 24. Alright, so we have the equal sign in the middle. Everything, it's like a teeter-totter. Everything on the left, it's supposed to be a 1. Everything on the left is equal to what's on the right, which happens to be 24. And so we're going to start by working our way toward this x, and we're going to get rid of the 15, because that's kind of loose. It's hanging out here at the end. We're going to subtract 15 from both sides. 15 take away 15 is 0. And 24 take away 15 is 9. It took me a second for some reason. 1.5x is equal to 9. Okay. So the next step is, this is where we get the second step. We're not just done. We still have a 1.5x. And we can divide this. We could do a couple of things. We can change it to a fraction. This is kind of cool. This would be 3/2 x is equal to 9. That's the same thing as 1.5, right? And then you'd multiply by the reciprocal, which is 2/3. Multiply by 2/3. Remember that 9 is like over 1. And those get rid of each other. Those cancel out, leaving you with x on the left. And then 9/3 is the same as 3. 9/3 is the same as 3, so 3 times 2 is 6. So x is equal to 6. Now that's fractions. I like the fractions. I could do it another way. I could just multiply everything by 2. Let's look at that. If I have 1.5x is equal to 9, and I just multiplied by 2, because I don't like that decimal. And 1.5 times 2 is something you probably should be able to do in your head. It's 3. So 3x is equal to 9 times 2 is 18. And then I go ahead and divide both sides by 3. This is the second step, kind of continued. 3/3 is equal to x, and 18/3 is equal to 6. So I got 6 both times. I also could just do the standard thing. I like the more creative routes, but you could just divide by 1.5. The problem is that you'll be tempted to get out your calculator, and I don't want you to do that. I want you to be able to work these through without. So x is 9 divided by 1.5. So you're tempted to just get a calculator out there instead of go ahead and follow through. 1.5 into 9. And then you got to move this decimal over, which means you got to move this decimal over and add a 0, make it 90. So it's really 15 into 90, because again we can't use that decimal. And then again we're kind of guessing, which is why I like the fractions and the second method here. 15, let's guess 6. 6 times 5 is 30. 6 times 1 is 6 plus 3 is 9, and we have no remainder, so 6 is the answer. We kind of already knew that. Anyway, you can see multi-step equations get a little more difficult, especially if you're showing your work like I did and you're not using a calculator. Both things that are important when you learn algebra. Please don't use your calculators. Put them away. There are times when I will let you use them, and hopefully we talk about that. Here's the second one. Combining like terms is an important thing you need to know for multi-step equations and for algebra in general. Like terms are ones that have like x's. X plus x, those are like terms. That's equal to 2x. Or if I say 2x plus 3x, those are like, and they can go together. They become 5x. Okay. If I have 2x plus 7, now it's not 7x, it's just 7, so I can't put them together. You kind of have to think of x as like a box of cookies. I have 2 boxes of cookies plus 7 cookies. how many cookies do I have? Well, I don't know, because I don't know how many are in the box. If there are 10 in a box, then I could say, well, that's the same thing as 2 times 10 plus 7. And I could come up with 20 plus 7 is 27. I could come up with a number. But I don't know what x is, or I might not. And so as long as x is just an x, I can't combine it with 7. You can't put them together. You also cannot put together an x and a y. So I don't have 2 of anything here. X plus y is not 2xy. That doesn't work. They're different. They're not like. If I have a 3 and a 4, those are similar. Those are like, so I can put them together. But if I have a 3 plus a 4x, I'm stuck. I can't put those together. All right. So that was just a real quick review. Let's see if I can get rid of these. There we go. And we'll try the problem that they give us, and we'll just remember those things that we learned. 8x, or that were reviewed, minus 6x minus 25 is equal to negative 35. All right, so this is a like term, and this is a like term. This is a like term, and this is a like term. I can put my 2 x's together, and I can put my 2 regular numbers together, my integers here. And I'll just do that. 8x take away 6x is 2x. Those combine because they're like, and they become one term. Now I'm going to just rewrite it because I like to show my work. I combined these two, and they're together now. But this and this are on opposite sides of the equal sign. But they still need to be combined. So I'll just go ahead and I will add 25 to this side to get rid of it over here, and add 25 to this side, so that, because you have to do to both sides of the equation, that disappears, and I'm left with 2x on the left side of the equation. And then I have to figure out what the difference between negative 35 and positive 25 is. And again, remember, it's 35 minus 25, which is 10. And so 2x divided by 2, x is equal to 5. Okay, the next set of problems is using the distributive property. Okay, so you're writing this down. Make sure that you get it. This is another great one that I love, but some students don't. You'll love it when you get used to it. Let's make that look a little better. I'm looking at two things at once. 1 minus 5x. That looks a little nicer. My handwriting's not perfect, but it's okay if I'm careful. Yours should be at least as good. Alright, so 2 times 1 minus 5x, so this is 2 times everything, plus 4 equals negative 8. So the distributive property, we just have to multiply 2 times both of the terms. Now we talked about adding like terms a minute ago, but when you're multiplying, it doesn't matter so much. You just have 2 of whatever it is. It's just like regular multiplication. You have 2 times 1 is 2 ones, so that's 2. It looks like this. And 2 times 5x's is kind of like 5x plus 5x, or, it's 2 5x's, but they're both negative, so it's, well, let's see, I could write that the other way. Times minus 5x times 2. Well, I guess I still had to write it that way. Anyway, there's the 1 times the 2 and the negative 5x times the 2 plus 4 equals negative 8. And I sometimes skip that step because I can just go 2 times 1 is 2. 2 times negative 5x is negative 10x, because 5x twice is 10x, and it stays negative. Plus 4 equals 8, negative 8. Okay, so we could skip this if we're comfortable with the distributive property, but this is important for you to see what is happening when you distribute. And then I combine my like terms. These two terms go together. Now what I need you to understand is the negative term is connected to the 10x. It's not connected to the 2. This 2 doesn't have a sign, which means it's positive 2. So it's positive 2 and positive 4. That becomes positive 6 minus 10x. The minus sign stays with the 10 equals negative 8. All right, now we're going to get a little silly here because we're going to do some strange things. We talk about multiple step problems. We're going to subtract 6 from both sides because we have a positive 6 and we'd like to get down to just an x. That leaves us with negative 10x. And what's a negative 8 and a negative 6? Well, you add them together, which is 14. And because they're both negative, it stays negative. Okay? And then we move on to the last step, I think, almost the last step, where we're trying to get the x by itself. We divide both sides by a negative 10. And negative 10 over negative 10 is 1, which just leaves us x. And negative 14 over negative 10, the negatives cancel out and becomes positive. Negative divided by a negative is positive. And I have to fix this because it looks like I wrote a 10 up there and it's really supposed to be a 14 on top and a 10 on the bottom. Okay, so now the only final step is just to rewrite it so that it's like a simpler fraction. The negatives disappear and 14/10 becomes 7/5. Hopefully that made sense. The book came up with a decimal, which is really weird. I guess it's not that weird because when you divide by 10, it's pretty easy. 14 divided by 10. Oh, I did it again. 14 divided by 10. Whenever you divide by 10, you just move the decimal over. So it's 1.4. It's still 14, but the decimal comes back a place. So 1.4 is what they had. Usually in algebra, we leave fractions alone and we just keep them. I guess they thought since it's so easy to divide by 10, they just changed it to a decimal. Either answer would be acceptable to me, even if it doesn't agree with the book. That's it. That's kind of a long video, but there's 3 really important things in there. Make sure you practice them. Make sure you've taken notes.